The weighted mean is just in many ways a shorthanded way to calculate uh, the uh, the mean that we've been calculating all along. So while it's laid out slightly differently, um, it should come quite natural once we understand what we're actually trying to do here. So the weighted mean is most useful when we have repeated values in a certain data set. And so rather than summing up each of them individually, we can kind of shorthand it and group them together. And so let me just, by way of an example, I think this will sink in more. So let's say we have some employees working for us. Okay, and some of the employees earn $17 an hour, some earn 19, and some earn 22 $22 an hour. Okay, and it turns out that we have 4 2 and 6. Okay, so we have 12 employees working for us. Now, if we had that all laid out in data, we would, in a data set, we might have a big long list of them, and it would just keep going, and we could sum that up with the method we did, right? So we could use the mean is equal to the sum of x divided by n. Actually, in this case, it'd be uppercase N because we are talking about the population. Let me just double check something. Okay, so when we were to do that, so that would be 17. We could write this all out: 17 plus 17 plus 17 plus 17 plus 19 plus 19 plus 22 plus, and so on, right? And that would get us to the correct answer. We would divide then by 12, and we'd come up with the answer. Now, an easier way to write that might be something like, I'm gonna write it down first. So let's first have a sum of W x and then divided by the sum of w. Okay, where w is the weight, and the weight is simply going to be the number of times this value shows up. So in many regards, this is the w, and this would be the x. Okay, and so in that way, we can say this is now 4 times 17 plus 2 times 19 plus 6. I'm still going to run out of room. Times 22. Okay, and this is probably actually, if I asked you to take the average of these, this is the natural way in which you would do it. And then we're going to divide by the sum of w, which again is 4 plus 2 plus 6, which is still going to be 12. Okay, so the weighted mean simply is kind of a shortcut for us as far as what we're doing mathematically. And we would still come to the same answer, right? And that would be what, 68 plus 38 plus 132 divided by 12. You can finish the math, but that's what we would end up with. And one other way to think about this, and this might be helpful not as much now, but down the road, is let me rewrite this, and I'm gonna factor the 12 out into each of these. Okay, so I'm gonna rewrite that, trying to remember what I just wrote. So again, we just had 4 times 17 plus 2 times 19 plus 6 times 22. Okay, divided by 12. Now, and that's our mean. If I factor this out, or if I break up this fraction and I say, okay, this is actually 4 divided by 12 times 17 plus 2 divided by 12 times 19 plus 6 divided by 12 times 22. I actually can think of this in the fraction form, or if I take it one step further, the percentage form. So 0.33 or the decimal form. 0.33 times 17 plus, what is this, 0.166 times 19 plus 0.5 times 22. Okay, and I just want to highlight that this weighted mean can be quickly shifted or transformed into just a percentage-based mean. So we know that a third of the time, or a third of our employees make $17 an hour, half of them make 22, and the other 16% make 19. And so the weighted mean and calculating a mean based around percentages are one and the same. And so we don't focus in on that as much here in this chapter, but I do think it's a useful way to think about it, and that oftentimes can be an easier way to do these calculations. Yeah, so we'll leave it at that, but that's really what the weighted mean is about, and we will use this. We'll see this later down the road in the semester as well.